All right, we've all been there. You're in that slow, shuffling line, the quiet dread building as you get ready to pull out your laptop and take off your shoes. It feels like this bureaucratic nightmare designed just to test your patience.
Yeah, that about sums it up, right? You're just standing there, annoyed, impatient, wanting it to be over. But what if I told you that what you're stuck in isn't really a line at all?
Exactly. If you could just strip away all the agents and the gray plastic bins for a second, what you'd see is actually a massive industrial engineering problem, a problem of pure, unadulterated throughput. I mean, think about the scale here. A big airport has to move over 100,000 people and all their stuff through just a few narrow choke points every single day. That's like trying to funnel the entire population of a small city through a handful of doorways. And the stakes? They're absolutely astronomical, because if that flow stops, even for a couple of minutes, the whole terminal backs up. It overflows. Then flights start taking off empty, and pretty soon the entire global airline schedule starts to shatter. It's this constant, looming threat of total collapse.
So, for this explainer, we're not going to focus on the X-ray scanners or what they're trying to find. No, we're going to look at the physical, mechanical system that's been built for one reason and one reason only: to keep people moving, no matter what.
And you know what? That machine starts working on you way before you even get close to a conveyor belt. It all starts with the design of the queue itself. Okay, so why the snake? Why the back and forth? Well, a straight line of all those people would literally stretch for half a mile. It would completely paralyze the terminal. But by folding it back on itself like this, you create what engineers call a high-density holding tank. It's a buffer that neatly contains all that chaos in one defined spot. And this is actually a classic strategy from something called queuing theory. By funneling everyone into one single line that only splits at the very last second, the whole system can absorb friction. So if one person is super slow at one scanner, the whole thing doesn't just grind to a halt. The flow just kind of diverts to the next open agent. It's actually a masterpiece of operational design. So you finally make it through the maze, and you arrive at what used to be the system's absolute biggest point of failure, the belt. You remember how this used to be, right? The old system was brutally linear. One person had to do everything, grab a bin, unpack their entire life, push it onto the belt before the next person could even start. It was like watching a chain reaction in slow motion. And that's the absolute killer, right there. This whole multi-million-dollar high-tech operation was completely held hostage by the one person who couldn't find the zipper on their carry-on. It was a crippling, fundamental design flaw. So to fix this, engineers had to completely blow up the old model. They had to break that single-file line and go parallel. And this is the result, the automated screening lane. So instead of one single drop-off point, you now have up to 5 parallel stations. 5 different people can all get their stuff ready at the exact same time. The potential for moving people through is it's night and day. And here is the real magic. If the person in Station 1 is taking forever to get organized, who cares? If you're in Station 3, it doesn't matter to you at all. You just slide your bin onto the belt and you go. Your speed is finally disconnected. It's decoupled from theirs. But of course, when you solve one huge bottleneck, you almost always create a new one. All these people moving so much faster now need a gigantic, non-stop supply of empty bins.
So, seriously, where did they all come from? The old way was just clumsy. Staff had to literally drag huge stacks of them from the end of the line all the way back to the beginning. The new system, though, has this incredibly elegant solution that's hiding right under your nose.
It's a hidden, automated circuit. When you grab your bag, your empty bin drops down a ramp onto a high-speed return belt that's running right underneath your feet. Then, a little elevator just lifts it back to the start. It is a continuous, closed loop that makes sure the front of the line never, ever runs out of bins. And the final piece of the automation is the sorting. See, every single bin has a little RFID tag. If the scanner flags a bag for a manual check, the main belt doesn't stop. A little mechanical arm just instantly pushes that one specific bin onto a sidetrack while all the cleared bags just keep flowing right on through. No slowing down. So let's zoom out for a second. When you put all of these pieces together, you've got the queue acting as a buffer, the parallel stations as the engine, the hidden return belt as the supply chain, and the automated diverter as the sorter, you realize you're not in a line anymore. You are inside a finely tuned spatial sorting machine. And the whole point of this entire machine is to take the most chaotic, unpredictable thing in the world,
us, people, and gently force all of our messy movements into a rhythm that is predictable, measurable, and most importantly, that never stops. Because at the end of the day, in our hyper-connected world, everything relies on constant motion. That is the one fundamental law that keeps the entire global travel system from grinding to a halt.
So the next time you find yourself standing there in your socks, take a second and look around. You're actually standing right in the middle of a brilliant hidden machine. And it kind of makes you wonder, what other invisible systems are all around us, just hiding in plain sight?